So before going to understand the smart grid concepts, let's first try to understand the brief history of the power system network. So the history of electricity starts with the demonstration of electric conduction by Stephen Gray. So he invented glass friction generator in London, Germany to demonstrate how electricity have the conduction. Now, in 1800, uh, Alexandro Volta from Italy invented battery. So in 1800, we came to know how to store the electricity. In 1808, Humphrey Davy developed first arc lamp for illumination. In 1820, Hans Christian Ørsted demonstrated the relationship between electricity and magnetism. Now, in 1820 itself, Michael Faraday and Joseph Henry invented the primitive electric motor. In 1831, Michael Faraday and Joseph Henry documented that electric current can be produced in a wire moving near a magnet. So that became the principle of generator, which you commonly uh, know with the name of Faraday's law of induction. In 1832, the first rudimentary dynamo was invented by a Frenchman called Hippolyte Pixii. Now the problem with this dynamo was that the power output was very intermittent. So in 1860, Antonio Pacinotti improved this dynamo to provide the continuous DC power. In 1867, Warner von Siemens, Clark's Wheatstone, and S.A. Varley nearly simultaneously devised the self-exciting dynamo that is nothing but our first electric generator. So these three people uh, developed this electric generator independently but almost at the same time. In 1870, a Belgian inventor, Genob Graham, devised a dynamo that produced a steady direct current which was well suited for the electric motors. Now, by 1877, the streets of many cities across the world were being lit up by arc lighting. So, arc lamp was developed in 1808. So, it took nearly 70 years to uh, become a norm for lighting up the cities. Now, in 1879, the Thomas Alva Edison invented the incandescent lamp, which was the biggest rival of arc lighting. In 1881, two electricians built Watt's first power system in England, which was powered by two water wheels, and the output was AC, and it was supplying power to 7 arc lamps at 250 volts and 34 incandescent lamps at 40 volts. The issue with this power system was that the supply to the lamps was intermittent. Now in 1882, Thomas Edison and his company, Edison Electric Light Company, developed first steam powered electric station on Pulse Street in New York, which was powering approximately 3,000 lamps for their 59 customers. So this power station was a DC power station. So the issue related to this power station was that the power could be supplied up to 800-meter distance only. Now in 1882, in London, Lucien Gollard and John Dixon Gibbs demonstrated the secondary generator. So although they call it a secondary generator, but it was our first transformer to be used in real power system. Now in 1885, Otto Titus Blathy of Gens and Company, which is in Budapest, perfected this secondary generator developed by Gollard and Gibbs by providing it with the closed iron core and thus obtained the first true power transformer. So the power transformer which we see currently in the power system network is 135 years old. Now in 1885, George Westinghouse, who was an American entrepreneur, obtained the patent rights of Gollard Gibbs transformer. In 1886, one of the Westinghouse engineer named as William Stanley proposed parallel connection of transformers and also proposed enclosed loop of iron core of a transformer to improve the voltage regulation of the secondary winding of the transformer. Using this knowledge, he built the first practical transformer-based alternating current power system at Great Barrington, which is in Massachusetts, and this was done in 1886. In 1888, Westinghouse also licensed Nikola Tesla's US patents for polyphase AC induction motor and transformer designs. By 1888, the electric power companies built thousands of power systems which were both in AC as well as in DC in United States as well as in Europe. During this time, rivalry between Thomas Edison and George Westinghouse companies grown into propaganda campaign. So both were campaigning to show the superiority of the form of transmission. That is, whether AC is better or DC is better. So this series of events are known as war of currents in the history of the power system network. In 1891, Westinghouse installed a first major power system designed to drive a 100 horsepower, that is close to 75 kilowatt synchronous electric motor, which was the first attempt to use electricity beyond lighting. Mikhail Dobrovolsky of AEG and Charles Eugene Lancelot Brown of Machin Fabric or Lincoln built first 175 kilometer 15 kilovolt, which was the record at that time, a three-phase transmission line from Laufen to Frankfurt for a electrical exhibition in Frankfurt. So this was the first attempt to send AC power over a long distance. Now AC-DC competition came into end when Edison General Electric was taken over by its AC rival, that is Thomson Houston Electric Company, which later became General Electric. Now in 1895, AC was chosen as a transmission standard with Westinghouse building Adams Beck 1 generating station at Niagara Falls. In 90, by 1930, reheat system turbines became the norm because after choosing AC as the transmission standard, lot of work was done on steam turbine side, and reheat steam turbine became the norm by 1930, and unit rating reached up to 300 megawatt output level. And after that, by 1940, we were consistently increasing the temperature of the steam turbines. Now in 1936, first experimental HVDC line using mercury arc valve was built between Schenectady and Mechanic Wheel in New York. In 1949, GE installed first commercial gas turbine for power generation of 3.5 megawatt at the Belle of Isle station of Oklahoma Gas and Electric. So in 1949, we started using gas turbine for generating the power. In 1957, a General Electric research group developed a solid-state PNPN switch device, which was a starting point for the revolution of power electronics. In 1957, Siemens also demonstrated a solid-state rectifier. 1965, first extra high voltage transmission at 735 kV took place at hydrocubic transmission line. In early 1970, a solid state device became standard in HVDC, and GE was emerged as one of the top supplier of thyristor based HVDC equipments. In 1979, a European consortium including Siemens, Braun Brewery and C, and AEG built HVDC link of more than 1420 km, 1.9 gigawatt plus minus 533 kV from Cabora Bassa, which is in Mozambique, to Johannesburg in South Africa using 3.2 kV thyristors. So this was the first attempt to build a long distance HVDC link, which was of 1420 kilometers. Now in 1982, the first transmission happened at 1200 kV level, and which happened in Soviet Union. Between 1980 and 1990, we see lot of innovations in fax devices such as SVC and STATCOM. So now, with the history of power system, you can see that how the various equipments and the technologies were evolved, and how DC was taken over by AC in the history, and later on towards the end of our 19th century, we again came back to the DC, that was in the form of high voltage DC transmission.